Okay, so today we are going to learn how to convert between different quadratic forms. Remember, I've been always referring to the different quadratic forms, so the vertex form, which we've already talked about in the previous unit or chapter, and then we've talked about the factored form shortly yesterday, and then then we expanded. You guys remember that? So you went with expanding, which means foil, and then to get to something that looks like this. Okay? So today we're going to do something similar. So yesterday we went from factored to standard. Okay? Today we're going to go from vertex to standard. Okay? So the three forms, I'm going to write them up here. So the three forms are vertex, which looks like this, right? And then you can get your vertex right away from it. And then we have the standard. And the standard is y equals ax squared plus bx plus c. And then we have the factored, which is y equals a x minus r x minus s. So we've already been introduced to the vertex form. We've already looked at the vertex form. We've already explained the different features of a vertex form, right? What can you find from a vertex form? The vertex, right? So the vertex, which is h and k, right? And then the vertex is the axis of symmetry, and the vertex is the y value is the optimal value. Remember that this is all been taught last right? Last unit, sorry. Now with the factored form, we briefly looked at yesterday, and we briefly just looked at something looked like the factored form. We haven't talked about it yet, okay? But what we did yesterday is we went from factored to standard by what we call expand, or we use the term foil.
That is x minus 5 or s?
S. Okay? Now, today we're going to learn how to go from vertex to standard, right? Also, we call the process expand. Okay? So this is the goal of today. So going from vertex to standard. Okay? Done copying this? All right. So I want you to look at both of these graphs and from
The second one is
just don't look at the equation, just look at the graph. What would be the y-intercept for the first one? 5, right? And then how about the second one?
also 5.
Also 5. Okay? How about the direction of opening?
Same direction.
They both open up, right? How about the vertex?
2.
2 what?
2 and 1.
2, 1? 2, 1. Okay. How about for the second one? 2, 1. Right? So the vertex is 2, 1, right? Okay. The y-intercept's 5. They open up. Do they have any zeros?
No.
So can you tell me, can you compare the two? Are they the same? Are they different?
Same.
They're exactly the same, right? They're exactly the same graphs. Okay? Now let's look at the equation that we have used to graph this. So for the first one, I've used the equation y equals x minus 2 squared plus 1.
Vertex form.
That's a vertex form. That's right. How about this one? That's a standard form. So basically, these two equations are equal to each other. They're the same equations. Just one is written in vertex format, the other one is written in standard format. Okay? How can I go from one to the other? This is the question. All right. Now, before we go, why do we use the vertex form and why do we use the standard form? Why do we have different forms? The reason we have different forms is because vertex form can tell us right away what the vertex is. We can use the step pattern so we can graph. So vertex form is one of the most useful forms you can have, especially for a graph. Okay. Now standard form is how they created it. This is the standard form. Okay, and then they came up with the other forms from it. Okay, so the standard form, you can only find one thing from the standard, actually two things. You can find the direction of opening, and you can find the y-intercept from the standard form. Look at this equation and tell me what information that we found on the graph that is included in your equation.
Y-intercept.
What's the y-intercept? 5. And where is it? It's right here. Right? So, always from a standard form, you can find the y-intercept. And you can tell the direction of opening is up because the a value right here is 1, which is positive. So it's going to open up.
Also, we have a horizontal
Not, you can't do that from this format. You can only do it from the vertex format. Transformation can only be said and looked at if it's vertex form. You can't look at transformation in any other form. Okay? So the only thing that we can tell from the standard form is the y-intercept. Are we okay with that? And then again, as I said, the direction of opening because of the A. Okay, so let's fill this out. What information about the key feature of the parabola can you take from each form? So an equation in standard form, which is this form, y equals ax squared plus bx plus c, tells the location of the y-intercept. An equation in vertex form tells the location of the vertex, which is HK. What else? Axis of symmetry and optimal value. So the axis of symmetry is the H value of the vertex, and the optimal value is the K value. So are we good? Now, vertex form can be converted to standard form by, what did I say earlier? Expand. So you're expand. So it's a similar idea of what we did yesterday. But instead of only having, okay, can I have your attention? instead of only having x minus 2 squared, right, this is what we did yesterday, right? Something similar to this.
Yep.
Now we have x minus 2 squared plus 1. We have things added to it. So we're still going to do the same, we're going to have to do the same process, but we're going to have addition to it. Okay? So let's expand that. So what would you do to expand this?
X minus 2 in brackets and another x minus 2.
Okay, so the first thing is to clone the x minus 2. Right, so write it twice. Okay? Now what do you do to expand?
You multiply both.
Brackets.
You multiply both.
That's right, so you fold the brackets, but the one is going to stay outside, right, for now?
Yeah.
Okay?
And then you have the output.
The like terms, yeah.
Like,
Good. So let's remind people who were not here yesterday. How do we do? Bless you. How do we do that? Okay. So how do I multiply x minus 2 times x minus 2? Where do I start?
X times x.
So the first,
Yeah.
right? So I multiply the first by the first.
Yeah.
So that's going to be x squared.
X minus 2.
Then I have to multiply, so foil, right?
Yeah.
First, outer, so it's going to be x times the negative 2.
Yeah.
So what do I get?
Minus 2x.
Negative 2x, yeah. Then
X times 2 times x.
negative 2 times x.
Negative.
Minus 2x.
Because you see there's a negative in front of the 2, yeah. And then negative 2 times negative 2, which is
Positive.
positive 4. Okay? So what we do, we call it FOIL, so first, outer, inner, last. Okay? So the first by the first, for those of you who were not here yesterday, then we have the outer 2, we multiply them together, can you see Jenna? And then we have the inner, and then the last terms. Okay? Now, but on top of this, I have plus 1, right? So plus 1 is going to be included right here. So yesterday we did all of this without that plus 1. Okay? Now we're going to collect like terms. Where do you see like terms here?
X 2x and 1
square minus 4x plus 5.
So what did you add?
Minus 2 minus 6.
So these two are like terms.
Yes.
So that's going to be negative 4x. And then I have 2 other like terms here, which is going to be plus 5. Right? I'm going to take you back up for a second. So this is what I had. This is what I ended up with. Is that right? They match, right? Good. Sorry?
Is it x to the power of
2.
2?
Yeah. Just the 2 was cut. Yeah. So these two, right? Because they have both x's. So I collect them and that gives me negative 4x. And then these are only numbers, so I collect them and it's gonna be 5. Okay? So you always look at which one has the same letter and the same exponent. Okay? Now, the next one is going to be with another thing added to it. So it's not only that I'm subtracting 4, I'm also multiplying by -3. So my A value is -3, my H value is -1, and my K value is -4. Okay? So how do I expand this in order to get to the standard? So you're going to follow the same thing, same idea. That math is very important in this case. So you're going to have to, so I'm going to rewrite this. You cannot bring a -3 in. It's not allowed. And this is what students tend to do the first step, is multiply by -3, right? And this is not right, because that -3 is not under the square root, you can't do that. Okay? So, the first thing you want to do is you want to multiply your brackets, okay? Because this is what math tells us. Alright? So I'm going to multiply, I'm going to FOIL. So same idea, I'm going to do first. I'm going to write -3. And I'm going to do first. So in this case, I'm going to keep the bracket. So it's going to be x squared. Outer, it's going to be plus x. Inner, it's going to be plus x. And last is going to be plus 1. Now you see in this case, I did not remove my brackets yet, right? Because I have that -3 that's outside. That has to be multiplied by everything inside the bracket, right? Now there's two different things that you can do here. You can simplify inside the bracket, collect like terms, or you can multiply the -3 and then simplify everything at the end. It's up to you.
Gives the same answer.
It gives the same answer. So let's just multiply, okay? So if I want to multiply -3 times x squared, that's going to give me
-3x squared.
-3 times x,
-3.
-3.
-3.
Good. So everything inside the bracket got multiplied by the -3. The -4 stayed without being touched. Now we can collect like terms, right? So if I look at this, I have -3x and -3x. They get added. So that's going to be -6x. And then -3 minus 4, that's -7. So, recap, what I did here is I went from vertex to standard by expanding. Right? Who gets this?
The only problem is the signs for me.
And that's why you don't want to mess this up.
I have to look into
So pretty much just leave the signs, because I have the same problem. Like, pretty much just leave the signs, like, where you see it.
Where? At the end when you're collecting?
Yeah.
So at the end when you're collecting, the easy way to do this is, so you have -3, it's always the number with a sign in front of it, right? So this is -3 minus 3. So if you're still not like 100% sure what your answer is, that's what you're gonna enter on the calculator, -3 minus 3, right? But technically if you wanna think about it, you're at -3, you owe me $3, and then you owe me another 3, right? So now you owe me 6. Right? So think about the negative as owing.
Okay.
Right? You owe me this much,
And then you owe me another.
you owe me another one. So you're gonna owe me 6. Let's say if you owe me 3, but then you gave me 4. Let's say if you have this, so -3 plus 4, right? If you owe me $3, but you gave me $4, so now I have an extra $1. right? So the answer is gonna be plus 1, right? It depends, I mean, the calculator should be giving you the right answer if you're entering it right in the calculator, right?
So I thought we were gonna do like minus times minus.
Well, you're not multiplying though. In this case, you're adding. When you're collecting like terms, you're adding. The only time you're multiplying is right here. When you have brackets and then you're multiplying. This is when you're multiplying. At the end right here, you're just collecting like terms. That means you're adding the terms.
Okay. If we have positive 3, so they're gonna cancel each other.
Yes, so if you have negative 3x plus 3x, they cancel each other to 0.
And this step is only for the negative.
What steps? Sorry.
Like this example. Because
So-
you left the negative 3 out of the brackets.
Yes.
So when it's negative, you always leave it out.
No, even if it's positive, right, you leave it out until you do your FOIL first. No matter what that number is, you're gonna leave it out. You're gonna do your FOIL, then you're gonna multiply it. Okay, let's do another example. Let's do this one. So I'm gonna write x minus 2 twice, plus 3. Okay, so move that's on the next page. Okay? Now, before you can multiply the 2 in, you have to FOIL first. So when I FOIL, what do I get? X squared minus 2x. Good. So, finish with the FOIL. Now I can multiply, distribute that 2 into my bracket by multiplying. Are we okay with that?
Times 2 is just obliterated.
Sorry, this one? Sorry?
Because the times 2, so actually never mind.
So this is gonna be, this whole thing is gonna be multiplied by 2. Okay? So, what do you get? 2 times x squared is 2x squared. 2 times negative 2? Negative 4. 2 times negative 2? And 2 times 4? Plus. Now, all what I have to do is I have to collect like terms. So my like terms are negative 4x minus 4x. So you owe me 4, now you owe me another 4. How much, what do I have?
8x.
Now you have 8x or you owe me?
No, we have negative.
Negative, yeah? And then if you do negative 8 plus 3, plus 8 plus 3, so that's positive 11.
We
Okay.
have to write the this twice though. So we don't have no space.
You can do them like basically just split your paper, right? You can do 3 sentences, 1. I want to go back to the previous question and finish it. Just want to finish copying. Okay. Can you go back up here? So that table belongs to the question that we did earlier on the previous page. That's a question right here, right, giving this equation. So, state the key features you can determine from the vertex form. So this is the vertex form. What key features can you determine from it? What is the vertex? -1, -4.
Reflection.
It's reflected, yeah.
Vertically stretched.
They're not asking you for the transformation, so they're just asking for the key features. So that means points. That's right. So the optimal value is what? Y equals -4. And the axis of symmetry? X equals negative. Okay? So remember that this belongs to the axis of symmetry, and the Y value is your optimal value. Now the question is asking you to expand, which we've already done on the previous page, right? What was the answer? Can you guys check your answer and tell me what it is? Y equals
x squared minus 4x plus 5.
-3x squared, right?
Or the -2? No.
The bottom.
Okay. Y equals -3 squared minus 6x minus 7.
Okay. What can you determine? What key features from the standard form can you find? So from this form, what key features can you find?
Up and down.
Y-intercept, which is what? Negative.
That's it.
That's it. There's nothing else you can find from the
Seven.
only one point, which is the Y-intercept. Okay, so this is what's gonna happen. You're gonna finish these two questions and you're gonna show it to me. So 1, 2, A and C. You're gonna finish these and then you're gonna show them to me. And then let's see how you're doing with this, and I'll decide what I'm gonna do next.